Everyone, September 29th. Alright, let's do this. Monotonic array. Increasing or monotonic decreasing? Array is monotonic increasing. Oh, it's just true and false if it's monotonic. Alright, so monotonic, we just check one by one. Alright. And if length is equal to 1, turn true. Okay. Otherwise, we can do larger than 0 or smaller than 0. Right? Then we say boolean trend shall be nums 1 minus nums 0 larger equal to 0. Ooh, what if they're equal? That is a good point. That is a good point. What if they're equal? So we'll go through them until we find the first one's not equal. Okay? Then we just say for int I equal to 0, int I equal to 1, I smaller than nums.length, and nums I is not equal to nums I minus 1, I plus plus. I don't like it. Nums.length and I minus not equal to nums I minus 1, I plus plus. All right, and then we say trend. Now we have a trend. Oh, I say if I is equal to nums.length, then return true. Alright, and then we'll say trend I and I minus 1. Okay. Oh, larger than 0. And while I smaller than nums.length, if nums I minus nums I minus 1 is not equal to and nums I minus nums I minus 1 larger than 0 is not equal to trend. Or return false. Oh, it's a bit complicated. It's more complicated than I expected. I wonder if there's another way to do this. I think there's another way. So if it's a monotonic array, oh, what? I think the first one's wrong. Oh, what the hell? Oh, what the hell? Sorry. It's equal to. I don't know why. Yep. I think I have another method. All right. No. Monotonic array. That means if I want to take things out, right? We can say while I smaller than nums.length. Okay. Right, and then we can say this is -2. No, -1. So we're thinking as a monotonic decreasing array, right? So which means if it's monotonic, so one side has to check for increasing, the other side check for decreasing. For increasing is just if I was thinking about like a popping, you know. Now you should just check the sign. The sign doesn't change. Yeah, I think we can just int sign. No, boolean. Right? And now basically say if nums I is not equal to nums j I minus 1, right? Oh, then you don't know the previous sign. Yeah, you don't know the previous sign. Oh, dude, we need to know the previous sign. Let's say int. Okay. Then we say if sign is 0, that means we haven't get a sign yet. Then sign shall equal to 1 if nums I is larger than nums I minus 1, else minus 1. Else if nums I larger than nums I minus 1 and sign no. What do you want? I think it's exclusive or sign larger than 0. Oh, then sign, yeah, right? I think this shall work, which means if both are true or both are false, then we're good, right? So else if both are true, both are false, but if this is a not, damn, how many parentheses can you put? If not, then we'll return false. Yeah, but you tell me I can simplify. Ah, nice. I think this one's easier. Ugh. I think it's not equal to. Yeah. All right, so that's done. All right, let's back to candy. Let's do some candy. N children standing in line. Each child is assigned a rating value given in integer ratings. You're given candies. These are children subject to the following requirement. Each child must have at least 1 candy. Children with higher rating get more candies than their neighbors. So the minimum number of candies you need to have to distribute the candies. So we have the ratings. Okay, then the children with higher rating gets more candy. The children with lower rating gets less candy. And the way I was solving it was, I go like valleys and yeah, it's a very complicated way. And I have a modifier ratings. So I have no intention to redo this. I think the point is just see. But what we're saying is if we have, I need to refamiliarize with the problem. 1, 0, 2, right? So this should have the maximum This shall so at least one. So I say this is 1. This can have 2, and this can have 2, right? Which means this is 1, 0, and 2. Yeah. Rising edge. This is the valleys. Set the middle to 1. Rising edge, increment the middle by 1. A peak, increment middle by 1. And also take the max if it's peak, yeah. And the rest ignore because these will be handled on this side. Yeah, no, I don't like this. I don't like my solution. First, make sure your children with a higher rating get more candy than its left neighbor. Second, make sure your children with a higher rating get more candy than its right neighbor. Okay, so if I have 1, 0, 2, first round, everybody is higher. So if I rate this as 1, then this becomes 0. Then it's left neighbor. So I say I don't get any. Then it's left neighbor. Do you fill all the zeros first? First round, make sure it gets more than its left neighbor. Oh, I saw. Initialize everything to 1. Then run. If you're larger than the next left, so you add 1. Nothing gets added. Oh, this one I saw would become 2. Now we do this side. So if it's more than so. Oh, what? How? The left to right pass. And the right to left pass. Yeah, so you do this pass, right? You do left to right. Then anything, if it's bigger on the left, if you are bigger than this, then will increment. So let's say if left to right I, no, if ratings I is smaller than ratings I plus 1, right? Then this plus 1 will equal to I plus 1. On this side, because this is not larger than this, so you'll maintain. So the result is going to be the maximum of these two. No. Maximum of these two. And maximum of these two. So max of this I plus 1 is equal to max I plus 1. So this is definitely bigger than I and R. So this way, when this smaller than, then we can guarantee that the maximum of this will be smaller than this. Ooh. That's it. Proved it. I dealt with this in the past. I think I read it. Okay. Just write it. Not this one. Do a left to right pass and make if ratings I is larger than ratings I minus 1, make left to right I equals left to right I minus 1 plus 1. Initialize all positions to have 1 candy. Do a right to left pass if ratings I is larger than ratings I plus 1. Make right to left I equals right to left I plus 1 plus 1. The result. No, it should be res. Should be the maximum of this and I. To prove this method, right? To prove, suppose we have ratings I is larger than ratings I minus 1. Let's call it J. Then left to right I at J shall equal to left to right J minus 1 plus 1. Right. Left to right gives right to left gives J equal to, since yeah, That is no addition. Yeah, no with no addition. Then result j equal to maximum j right to left j. Result j minus 1 maximum left to right j minus 1 plus 1 right to left j minus 1. J minus 1 j minus 1. Apparently j is larger than j minus 1, which fits what the ratings want. Okay, so what we need to do is to have int res shall equal to new int array stuff fill. New int ratings length 1. Is that right? No, I think it's this. And then here, we call array stuff fill. We put res in it. Okay. Then we say left to right for int I equal to 1, I smaller than ratings length, I plus plus. Okay. So if num ratings I larger than ratings I minus 1, then res I equal to res I minus 1 plus 1. Okay, then we say right to left int j equal to ratings dot length minus 1, j large equal to 0, j minus minus. If ratings j is larger than ratings j plus 1, res j shall equal to math.max res j and res j plus 1 plus 1. And then int, oh, shouldn't say int res because it's not res yet. Candies. They gotta have a Java reduce stream.reduce. Okay, can we say candies dot stream dot, oh, sum? Oh, I cannot call stream. Alright, so arrays dot as list. Can I do that? No. How do I turn array? I think it's not the first time I do this. Yeah, you do that, right? Arrays.asList. List of. List of dot stream can be replaced by stream of dot no, it doesn't have some. What do we have? We have map, collect, count, distinct, filter, drop, flat, limit, mean, peak. We have reduce. Ain't no sum. Okay, so we do reduce. Accumulator as the first, binary operator. What's a combiner? I don't understand. So item accumulator is what you want. What's the last one? Takes two parameters, a partial result of the reduction and the next yes. Combiner, two parameters, a partial result of reduction. Next element, function used to combine the partial results of the reduction. When the reduction is parallelized, which means I don't really have to. So, because it's, I think, thread safe, right? So accumulator, and then we have AB, A plus B. So I'll return this. That's interesting. Huh. That's interesting. Stream reduce. Partial result. Why would is it int? Sequential string contain a single element. How is this an int? Alright, screw this. We'll have to loop anyway. Sea of candies. It's just one more line. Alright? I can live with that. I can live with that. I don't have to figure all those other things out. Interesting. Out of bound. Yes, out of bound, sorry. Oh, so good. Alright, so that will be it. Jesus. That will be it. Alright. Okay, I'm gonna copy this and then we're gonna call it. So one more thing that I like to say today is I have been dealing with some deployment issue with Lambda. It's the first time deployed to AWS Lambda that I hit a problem of memory. So I actually have memory issue. I need to increase the memory size, and then I also have to increase the timeout, both. It's quite fun to debug all that. But anyway, that's a story for another time. All right, I'll get off right now.